To find the value of y in this nice exponential equation, I might say, it's a mass Olympiad question. We're asked to find the value of y. We need to take the natural log of both sides. But can this really give us a real solution? Let's find out. If we take the natural log of both sides, that expression is going to give us the natural log of 1 to the power of y, right? And this will be equal to the natural log of 2. Now, considering the natural log of these two, recall that if you have the natural log of in of x to the power of a, this can be equal to a multiplied by the natural log of x, right? So if we are given that, that tells us that automatically our y will be multiplied by the natural log of 1, and this will be equal to the natural log of what? Of 2. Now from this expression, you can see that the natural log of 1 is equal to 0. So if that gives me 0, then our y multiplied by 0 will be equal to the natural log of what? Of 2. So this expression will now give us y multiplied by 0 is equal to 0. So as 0 will be equal to the natural log of 2. Now when you check the natural log of 2, I want you to point your computer or your calculator. You find out that the natural log of 2 is 0.693. From my own side is 0.693, and so is 0.696 equal to 0? No, this is not equal. So as a result, this is not a real what? A real solution. There's no real solution to this question that is given to us. The only solution that we can get for this question that is given to us is a complex solution. So how do we find the complex solution to this question? We're going to find the complex solution using what we call the Euler's formula. Now, how do we use the Euler formula to find the complex solution to this question? Now, let's find out. To use the Euler formula states that if we have, it states that the exponent of yx can be equal to the cos of x plus the imaginary of sine of what? Of x. So if x is exactly what we are looking for, we are going to make some serious assumption. So the e is the base of the natural logarithm. That's the natural logarithm of this is imaginary x. So the I is the imaginary unit, while the S is the angle in radian. So if we take the value of at x equal to 0, we'll find out that natural logarithm, which is e of I, will multiply what? 0, right? And that will be equal to the cos of 0, right? Plus imaginary multiplied by the sine of what? Of 0. Now the cos of 0 and the sine of 0 will give us what? The natural logarithm I multiplied by 0 will now be equal to the cos of 0 is going to give us 1 plus the imaginary multiplied by the sine of 0 is 0. So if we multiply that, we're going to have natural logarithm multiplied by 0 to be equal to 1, because this multiplied by this is 0. So if this can be equal to 1, we'll take that to be the result of that expression. Now, that is not the solution. Now, let's go ahead to also assume that our x is equal to 2 pi k, where k, we can say k are elements of z, they are elements of an integer z. So if we represent that or insert that into the Euler's formula, we're going to find that expression to now become, that expression will now become e to the power of the natural logarithm of this multiplied by 2 pi k, and that will be equal to cos of 2 pi, right? And that will be plus the natural log of sine of 2 pi. Since k are elements of an integer, this is the radian which we are going to find the cos and the value. If you look at 2 pi, remember from the law of from radian, pi is equal to 180. So 2 pi is equal to 2 pi will be equal to 360 degrees. So if you find that, you find out that E I multiplied by 2 pi k will be equal to cos of 360 is equal to 1 plus imaginary multiplied by sine of 360 is equal to 0. So you find out that our natural logarithm of this multiplied by 2 pi k will be equal to 1. So we'll hold this equation to a high esteem as equation 2. So from here, we are going to find the value of y when we compare this with the original question we are given. What's the original question? We are given that 1 to the power of y is equal to 2. So if we assume that our natural logarithm of imaginary multiplied by 2 pi k is equal to 1, and we know that 1 to the power of y is equal to, according to the expression, 2. So we can easily take that to become 1 to become e to the power of I multiplied by 2 pi k, right, all to the power of y is equal to 2, because our 1 is exactly equal to this. So when we simplify this, we're going to find the value of y. Now to simplify this, what we need to do is to take the natural log of both sides. Now let's take the natural log of both sides. This will give us the natural logarithm of pi multiplied by 2 pi k what? Ky multiplied by y, and this will be equal to the natural logarithm of what? Of 2. Now if we multiply this, remember the law of logarithm, that this power will multiply the natural log. So that will give us I multiplied by 2 pi k, which is multiplying y, will multiply the natural log of e, and this will be equal to natural log of 2. Now the natural log of e, remember, is equal to 1. So if we apply that over here, we're now going to have I multiplied by 2 pi k y to be equal to be multiplying by 1, which is the value for in of e, and this will be equal to the natural log of 2, right? Good. So if we simplify that, we are simply going to have this to become I multiplied by 2 pi k multiplied by y to be equal to the natural log of 2. Now we can simply find the value of y if we divide both sides by the imaginary multiplied by 2 pi k and divide here by imaginary multiplied by 2 pi k, and so our y will be equal to, the value of our y will be equal to the natural log of 2 multiplied by I multiplied by 2 pi k. So let us simplify this by removing the imaginary from the denominator. And to do that, we're going to multiply both sides by the imaginary. So if we do that, we'll have the natural log of 2 divided by imaginary multiplied by 2 pi k. And when we multiply this by imaginary divided by imaginary, then this will be what? From the denominator, we'll have our y to be equal to the imaginary multiplied by the natural log of 2, and that will be divided by imaginary square, right, multiplied by 2 pi k. Great. So recall that from our complex number, the imaginary square can be equal to -1, right? So if that is applied, we'll have in the next stage, we'll have our y to be equal to imaginary multiplied by the natural log of 2, and this will be divided by -1 multiplied by 2 pi k. So that will simply give us that value of y to be equal to -I multiplied by the natural log of 2, and this will be equal to divided by 2 pi what? K. Now recall that k cannot be removed because k, as long as k represents elements of an integer z, this value remains true, and it remains a solution to that complex, to that equation that is given to us there. So our y will be equal to negative imaginary multiplied by the natural log of 2 divided by 2 pi k. So as long as k are elements of an integer, and as long as k is not equal to 0, this remains our solution. And recall that if k becomes equal to 0, then the value of y will be equal to, will become undefined. So as long as k is not equal to 0, this is the complex solution to that equation that is given to us above here. I know you did enjoy watching this math solution. Don't forget to give it a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more mathematics solutions. Thanks so much for watching, and bye-bye for now.